Here we have IIT JEE Main mathematics problem. Okay, let's go with the question. The product of all the rational roots of the equation x square negative 9x positive 11 the whole square negative x negative 4 times x negative 5 equals to 3 is equal to. Actually, we have to find the rational roots for the given equation, and then we have to find the product of all the rational roots of this equation. Okay, now let me write the given equation as it is. That is x square negative 9x positive 11 raised to the second power negative x negative 4 times x negative 5 equals to 3. Okay, here let's consider the trinomial we have over here. This trinomial is raised to the power of 2. Okay, when I try to expand the square of this trinomial, then I'll be getting a term with x square raised to the power of 2. So this is equal to x to the fourth power. That is, when I expand the square of this trinomial, I'll be getting a term x to the fourth power. Then the degree of this equation will be 4. There is the largest exponent of the variable x in this equation is 4. Since the largest exponent is 4, there is a degree is 4, we'll have 4 roots for this equation. But our aim is to find the product of all the rational roots. That is, among those 4 roots, we just have to get only the rational roots. So how do you have to get the rational roots among the 4 roots? Okay, now let's start solving this one. Okay, in my first step, I keep the first term as it is. That is x square negative 9x positive 11 the whole square negative. Now let me multiply these two binomials using the FOIL method. That is, first let me multiply the first terms x, and I'm getting x square, and then I multiply the outer terms x and negative 5, I'm getting negative 5x. Then let me multiply the inner terms, negative 4 times x is negative 4x, and let me multiply the last terms, negative 4 and negative 5, I'm getting a positive 20 equals to 3. Then I'm getting x square negative 9x positive 11 the whole square negative x square. So when I combine negative 5x and negative 4x, I'm getting negative 9x positive 20 equals to 3. Then I'm getting x square and negative 9x positive 11 the whole square negative x square and negative 9x. Now I'm going to write this positive 20 as positive 11 positive 9. Okay, when I add positive 11 and positive 9, I'm getting positive 20 equals to 3. So here we have a question. What do we have to write this positive 20 as positive 11, positive 9? Because here, whatever stuff we have over here inside the parenthesis, x square negative 9x positive 11. So I would like to have the same stuff over here. That's why I'm writing this 20. I mean, split up this 20 as positive 11 and positive 9. Okay, now I'm going to assign a new variable for this stuff, x square negative 9x positive 11. That is, let t equals to x square and negative 9x positive 11. Because so solving this equation is little complicated. To make the solving process easier, I just assign a new variable t for this trinomial. So the same trinomial we have over here. Then the given equation will become what? So when I plug in t for this stuff, then I'm getting t square over here negative, and for this x square negative 9x positive 11, I can plug in t. Then I'm getting t positive 9 equals to 3. Okay, then we get so t square. Now we can distribute this negative sign to this t and positive 9. Then I'm getting t square negative t negative 9 equals to 3. Now let me subtract 3 from both sides. This positive 3 negative 3 will cancel. Then I'm getting t square negative t. When I combine negative 9 and negative 3, I'm getting negative 12 equals to 0. Okay, now I got a quadratic equation in terms of the new variable t. So what we have to do is I think this quadratic equation can be solved by factoring. For that, we have to multiply this constant term negative 12 by the coefficient of t square 1. When I multiply this negative 12 by 1, I'm still getting negative 12. Now I have to get two factors for negative 12, so that the sum of these two factors is equal to the coefficient of t. In this case, it's negative 1. Okay, I think negative 4 and positive 3 will work. When I multiply them, I'm getting negative 12. I mean, when I multiply negative 4 and positive 3, I'm getting negative 12. When I add them, I'm getting negative 1, which is a coefficient of t. Now we can get the two values of t from these two factors. Okay, to get the first value of t, I have to change the sign over here. Then I'm getting positive 4 as the first value of t. To get the second value of t, I have to change the sign of the second factor. Already it's positive. When I change the sign, it will become negative. So now I got two values for t. One is t is equal to 4, another one is t is equal to negative 3. Okay, now we can plug in the original stuff x square negative 9x positive 11 for t over here. Then I'm getting x square negative 9x positive 11 equals to 4. In this one also, we can plug in the original stuff for t over here. Then I'm getting x square negative 9x positive 11 equals to negative 3. Okay, now let me subtract 4 from both sides to get a quadratic equation standard form. So positive 4, negative 4 will cancel. Then I'm getting x square negative 9x. When I combine positive 11 and negative 4, I'm getting positive 7 equals to 0. And here I can add 3 to both sides. When I do so, this negative 3 positive 3 will cancel. I'm getting x square negative 9x positive 14 equals to 0. Here I got two quadratic equations in standard form, and as I said earlier, we'll have four roots of the given equation. That is two roots from this quadratic equation, two roots from this quadratic equation. So in all we have four roots for the given equation. Okay, so in those four roots we have to get the rational roots, and then we have to find the product of the rational roots. Okay, now let me solve each of these two quadratic equations. Okay, now let me continue on the next page. Here we have the two quadratic equations we got on the previous page. Okay, now let me try to solve the first one by factoring. For that we have to multiply the constant of positive 7 by the coefficient of x square, that is 1. 1 times positive 7 is positive 7. Now I have to get two factors for positive 7 so that the sum of the two factors is equal to the coefficient of x, negative 9. Okay, I don't think we'll be able to get such two factors. So this quadratic equation, I mean the first one cannot be solved by factoring. So you may have to use quadratic formula. But instead of using quadratic formula, better we can find the value for the discriminant of the quadratic equation. Because when I use quadratic formula, I think I'll be able to get rational roots. Because our aim is to get rational roots. Okay, so using discriminant of the quadratic equation, easily we can know whether we have rational roots or irrational roots for this quadratic equation. So the discriminant of the quadratic equation is b square negative 4ac. So the value of b is the coefficient of x. In this case, it's negative 9. So negative 9 the whole square. Negative 4 times the value of a is the coefficient of x square. In this case, it's just 1. And c is the constant term, which is positive 7. Okay, then we get negative 9 the whole square is 81, and negative 4 times 1 is 4, and 4 times 1 is 28. Okay, when I subtract 28 from 81, I am getting 53. Okay, so I got the value of b square negative 4ac as 53, and it's greater than 0. Since the value of the discount b square negative 4ac is greater than 0, this quadratic equation will have two real roots. But the value of the discount b square negative 4ac is not a perfect square. I mean, this 53 is not a perfect square. Since this 53 is not a perfect square, the two real solutions, I mean, the two real roots we are getting for the first quadratic equation will be irrational. So we don't get rational roots for this first quadratic equation. Okay, so we can skip the first one. Now let's try to solve the second quadratic equation we have over here. That is x square negative 9x positive 14 is equal to 0. Anyways, let's try to solve this one by factoring. For that, we have to multiply the constant of positive 14 by the coefficient of x square. 1 times positive 14 is positive 14. Okay, now I have to get two factors for positive 14 so that the sum of the two factors equals to the coefficient of x, that is negative 9. I think negative 2 and negative 7 will work, because when I multiply negative 2 and negative 7, I'm getting positive 14, and when I combine, I mean when I add them, I'm getting negative 9, which is the coefficient of x. Okay, then to get the first value of x, I have to change the sign of the first factor. So already it's negative. When I change this sign, it will become positive. So then 2 is the first value of x. And to get the second value of x in this quadratic equation, I have to change the sign of the second factor. When I change this negative sign, it will become positive, that is positive 7. Okay, now I got two roots of this quadratic equation. Both the roots are rational, 2 and 7. But for the first one, we have two roots, but both of them are irrational, because the value of the discriminant is, even though it's greater than 0, it's not a perfect square. Anyways, for the given equation, we got two rational roots. One is 2 and other one is 7. But our aim is to find the product. Product means we have to multiply the two rational roots. When I multiply the two rational roots, 2 and 7, I am getting 14. So the product of the rational roots of the given equation is 14. Okay, now we find 14 in answer choice A. The correct answer choice for this question is A.